All right, I want to use the theorems we came up with on a couple of examples here. These are the problems that you guys are going to have to do. So let's just remember what all of our theorems are. So I wrote them all up here. AA, that's angle, angle. Side, 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 or SSS. And side, angle, side. SAS. I didn't write AAA. Why not? Because, well, AA is the same thing, right? If we know the two angles are congruent, the two pairs of angles are congruent, we don't care about the third one because we know that one kind of comes for free. Okay. So what are we supposed to do here? Determine whether the triangles are similar. If they are, write the similarity statement and state the theorem that you use to prove that they are similar. I'm going to start with number 2, actually. I'll go back and do number 1. So number 2, CBA. Well, here's CBA. That looks like, if these two triangles are similar, that would go with FGH, right? That's kind of what it looks like. Now, we don't know. We have to check. What theorem would we use to figure out that they're similar? Well, we don't know anything about angles, right? It only tells us about sides. So we're going to have to use, we're going to try side, side, side similarity. We're going to try to show that CBA is similar to, so C would go with F, B goes with G, A goes with H. So CBA is congruent or similar to FGH. We're going to try to show that by SSS. Let's make this up bigger. Oh yeah, look at that. Okay, so what would my proportion statement have to be? Well, I'd have CB over FG would have to equal CA over FH would equal BA over GH. BA, GH. Okay. All right, so plug in my numbers. I know I've got, I'm going to write them up here. CB over FG. That'll be my first one. That's CB is 48, FG is 8. So 48 over 8. Then I've got CA over FH. CA is 84. FH is 14. And then I've got BA over GH. And I want to show BA over GH, that's 72 over GH is 12. And I want to show that all of these proportions are equal. Well, let's check it out. Alright, so I got my calculator, battery's up. 48 divided by 8 is 6. Alright, next one. 84 divided by 14 is 6. Looking promising. 72 divided by 12 is, oh look, they're all 6. So all of the proportions are equal. All the ratios are equal to the sides. So the side, side, side theorem says, let's pull it back over here. Side, side, side says, if the corresponding sides in two triangles are proportional, then the triangles are similar. Why is it over there? That's weird. Similar. Okay. Corresponding sides are similar, so we get CBA, is similar to triangle FGH by side, side, side. Okay. By SSS. I'm sure you can make this a little bit neater on your paper. Now, let's try number 1. So, we've seen these kinds of problems before, usually where these two lines, ST and DE, are parallel. This is the bow tie problem. And in those ones, we've got T and D end up being congruent, S and E are congruent, and then, of course, both sides here are congruent to vertical angles. So, what would we use to try to prove that these are similar? Well, you got to look at what you know first. I don't know that T and D are parallel. It's cool. I don't know that angle T and D are congruent, right? Because it hasn't told me that. I don't know that S and E are congruent. It hasn't told me that. All I've got are some sides, and I do know some angles. I do know that this angle here and this angle here are congruent, because those are vertical angles. They're alwaing congruent. It doesn't matter anything else. So I got two sides and an angle. Well, of my three theorems, AA, SSS, SAS, which one involves two sides and one angle? Just this one, just SAS. So if I'm going to try to prove it, it's going to be, I'm going to just put it up here, try SAS. And what am I going to be trying to prove? Well, I guess that UTS is similar to UDE, right? Because that's how these bow ties usually work, right? Is that the opposite sides match up each other. So I'm going to go UTS is similar to sorry, I forgot my U. UDE. Now, in order to prove the two triangles are similar by SAS, I need to show that the two pairs of sides are proportional and the included angle included angles are congruent. Well, here's my sides, SU, UE, DU, and UT, and the included angle I know is congruent. So I've got the included angle part fine, right? I've got angle DUE is congruent to angle TUS. All right. So that's already done. I've got the A part in SAS. So I've got the A part done. I got to do the sides though. So I'll do UE and US. I know those, so I'll do 16 over 39, and I will do DU and TU. Right. So that's 16 over 40. Now these will have to be equal for me to get. For me to use SAS to show that the triangles are similar. Well, 16 over 39, I mean, you can kind of see how this is going to go, but I'll do it anyway, just for the sake of completeness. 16 divided by 39 is 0.41. And 16 divided by 40 is 0.4. Okay, they're close, but no, they're not equal. The ratios are not the same, so the proportion statement that would have to hold does not hold here. So these are not similar. Okay? That's what you're going to do with each of these problems. And so with each problem, you've got to figure out, okay, like, number 4. What am I going to use to figure this out? Well, what do I have? I have two angles. If I have two angles, then I'm not going to be using side, 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 right? I don't know any of the sides. I only know two angles, so I can only use angle to angle. You get the idea. So that's it. You guys do the rest.